So today we have taken one question from ray optics light chapter, okay, where it has been given that two layers of liquid are given to you, okay. One layer is while above the layer of water. So let us say if this is the layer of water, the colored water, and the layer of oil above it, right? It has been given that the depth of or the height of the oil over the colored water is of 3 centimeter length, is of length 3 centimeter, right? And the layer of colored water above which this oil is floating is 5 centimeter. This is given to you as 5 centimeter, right? Now the thickness of the oil and water level is given to you, right? Now the refractive index of the colored water is given to you as 5 by 3. So the refractive index of this colored water, let us say the water which is colored, right? Let us say the mu 1 is the refractive index of this colored water, and this is given to you as 5 by 3, and the apparent depth of the two liquid appears to be 36 by 7 centimeter, right? So the apparent depth is given to you. So apparent depth as given to you into the question is of value 36 by 7 centimeter. 36 by 7 centimeter, right? Now from this it had been asked to find the calculate the refractive index of the oil. From here we need to calculate the refractive index of this oil. That means let us say the refractive index of the oil is mu2, and that we need to calculate, okay. So the all data in front of you, the height of the oil water level is given to you as 5 centimeter above which the oil is floating, and the height of the floating oil is given to you as 3 centimeter. Refractive index of the water level, the colored water is given to you as 5 by 3. We need to find the refractive index of the oil when it's given that apparent depth is 36 by 7 centimeter. My dear friends, hi Johnson. So my dear friend, we know the formula of apparent depth with respect to height, right? Apparent depth can be written as the thickness of the slab, right? Thickness of the water level or the liquid. Let us say T1 for the first medium divided by the refractive index of that medium, that is mu1, plus if there are n layers of water or any liquid, water, oil, grease, or any kind of, right? So we can write the thickness of this second layer divided by the refractive index of that layer, right? So from this, here the apparent depth is given to you as 36 by 7 centimeter, right? So write 36 by 7 centimeter over here, and into the RHS we have T1 by mu1. T1 is the thickness of the first, so that is, let us say 5 is the 5 centimeter is the thickness of the water level. So just 5 divided by mu1. Mu1 is given to you as 5 by 3. So just put up this value 5 by 3 over here, right? Plus T2. T2 is the thickness of this wire layer, that is 3 centimeter, divided by what? The refractive index of that wire, right? So we get the relation 36 by 7 apparent depth equal to 5 divided by 5 by 3. That means the height of the water level divided by the its refractive index plus height of the next layer divided by that refractive index like that, right? Hi, the ACT guy. Hi, very good morning, good evening, good day to you. Now just solve this is a simple equation. You can see this is a very simple equation, and you can easily calculate the value of mu 2, which is your answer. Okay, so let us calculate it. So this will give you 36 by 7 is equal to, you can see 3 going over above, and 5 will be cancelled out, right? 5 will be cancelled out, and 3 going into the numerator, plus 3 by mu 2. So just keep 36 by 7 minus 3 is equal to 3 by mu 2, right? And when you just solve it, you will get a, let me shift a little, my dear friends, let me shift a little. This will give 7 into 3, 21. So this will give you 36 minus 21 divided by 3, sorry, divided by 7, the LCM is equal to 3 by mu 2, right? And this will give you the value 36 minus 21 is nothing but 15. So 15 by 7, this will give you 15 by 7 is equal to 3 by mu 2, right? This will give you 3 by mu 2. And finally, when you solve it, you will get the value of mu 2 by cross multiplication. You just write the value of mu 2 as equal to 3 into 7, this one, 3 into 7 divided by this 15, right? So this will be coming as, if you divide 3 with 3, this 15, it will divide in 5 times. So 7 by 5. So this will be coming as 7 by 5. So what is the value of 7 by 5? That is the value of mu 2. So the mu 2 is coming at, when you divide it, 515 to decimal 0, 1.4. So my dear friends, mu 2 is the refractive index of the layer of oil. Okay, so the oil layer which is placed above this water, then the refractive index of this oil is calculated, and that is equal to 1.4. Okay, 1.4, and this is our answer, my dear friends, right? I hope you understand the solution, how we calculated. So just remember this one. Let me highlight with a different color. Okay, you need to understand that apparent depth is calculated by this formula. Suppose we are having, for multiple layers, maybe layer 1 of liquid over here, okay, above that, and layer 2 liquid is there, maybe above that layer 3 liquid is there, then our formula will be changed gradually like the same way as it happened over here, right? So if I will say this is layer 2, this is layer 1, this is on the top is layer 3, okay, and if the thickness of all this here, it is T1, that means the depth of the, or the layer thickness, this is T1, this will be T2, and above that the layer 3 is having the thickness of T3, right? Then into this case the same formula will exist, and the apparent depth for these 3 layers of water, oil, or maybe another liquid can be given as T1 by, and if the refractive index of the corresponding layers are mu1, mu2 and mu3, right? It should be known to you. If not, maybe one of this is a variable, and rest of the two are known to you, right? Mu1, mu2 and mu3. right? Then we can write by the relation of the apparent depth that T1 by mu 1 plus T2 by mu 2 plus T3 by mu 3, right? So in this way, as soon you go on increasing the layers above the layer, okay, the same will be happening, okay, the same relation will exist. Just take the depth of that label, that is the layer of the right ECT guy, I hope you understand it, right? Take the layer of that thickness of that liquid divided by the refractive index of that liquid plus depth of the another layer, that is T2. So T2 by mu 2 plus T3 by mu 3. Likewise, you just increase the layer and this will be going to be increased, right? So in this way, we can solve such question, my dear friends, right? So I think we are okay to, we have okay with this session, with this question. If you want me to discuss more, I can. Okay. Thank you so much for watching. Take care. Bye bye. Be connected.